Hi, and welcome to Lesson 7.1. Today our goal is to be able to use and apply the zero and negative exponent rules. Okay, let's think about what you already know. You already know how to simplify expressions where powers are being added and subtracted. You've learned how to do that a while ago. It's combining like terms. In Chapter 7, we're going to be learning how to simplify expressions where powers are being multiplied and divided. And that's what's new in this chapter. We're going to be investigating the zero exponent rule and the negative exponent rule in this lesson. Let's first begin by investigating the zero exponent rule. Let's look for a pattern. Here you're going to see I have a row that says 2 to the third power, 2 to the second power, 2 to the first power, all the way down to 2 to the zero power. So let's just evaluate that. 2 times 2 times 2 is 8. We know that would be 4, that would be 2. Now take a look at the pattern. To get from 2 to the third power down to 2 to the second power, you're just dividing by 2 because you're dropping one of the exponents. And then if that pattern continues, do you see here? If it keeps continuing, 2 to the zero power would be 1 because 2 divided by 2 is 1. Now let's go over here to this side. 3 to the third power. 3 times 3 times 3 is 27. 3 to the second power is just 1 less 3, so it's 9. 3 to the first power is 3, and so on. Again, you can see that we're dividing by 3. And if I continue that pattern, 3 divided by 3 is 1. So 3 to the zero power is also 1. It's true that any number to the zero power is going to give you the answer of 1. So any number to the zero power is always equal to 1. Be sure you're filling that out in your notes. That is the zero power rule. Always equal to 1. Okay, so let's give this a try. Let's say I have negative 4 to the zero power. Do you see how the 0 is touching the parentheses? So it applies to everything in the parentheses. The entire negative 4 brought up to the zero power. Well, anything to the zero power is always equal to 1. Answer would be 1. Now in this next example, 5 times n to the zero power. Well, I know n to the zero power is 1, so this would really be rewritten as 5 times 1, which would then be 5. And the last one, we have 1 divided by 7 to the zero power. Well, that would be the same thing as 1 divided by 1 because 7 to the zero power is 1. And so you could evaluate that and get 1. So you got to be very careful. The answer isn't always 1 if you have a product like 7 or 5 times n to the zero power. So you got to be careful. Okay, so we've got the zero power rule. Now we're going to move on to the negative exponent rule. Okay, continuing the pattern here. So do you see how if you look, we got 2 to the third power, 2 to the second power, 2 to the first power, 2 to the zero power, and then I continued 2 to the negative first power, 2 to the negative second power. So we're going to keep that pattern going of the dividing by 2, and 1 divided by 2 is half. So 2 to the negative first power would be half. And you can try it in your calculator and you can see. And if I divide by 2 again, I would get 1/4. And if I divide by 2 again, 2 to the negative third power would just be 1/8. Okay, let's take a look at the next row. So we're just going to continue the pattern of dividing by 3 to get down to the next answer. So dividing by 3, we get 1/3. 1 divided by 3 is 1/3. And if I divide that by 3 again, 1/3 divided by 3 is a 9th, and again is 1/27. So let's take a look. What do you notice? Maybe you want to pause the video and just take a peek here. What are you noticing? Let's look a little closer here. 2 to the third power and 2 to the negative third power. You have 8 and 1/8. What do you see there? What about 3 to the second power is 9 and 3 to the negative second power is 1/9? Are you noticing something? Do you notice that they're reciprocals of each other? Yeah, 2 to the third power is 8 over 1 and 2 to the negative third power is 1 over 8. They are reciprocals of each other. But let's take a closer look. How are we going to be able to evaluate 2 to the negative third power without using a calculator? How do I get the fact that that is actually 1/8? Well, let me show you what we can do. Let's first write this as a fraction. So we can see that 2 to the negative third power is really a numerator. What we can do is we can take that power and we can put it in the denominator. And as soon as we move it to the denominator, the exponent becomes positive. And what we would have left in the numerator would just be 1. So do you see that this is almost like reciprocals, right? 2 to the negative third power is the same as 1 over 2 to the positive third power. Now, if I continue to evaluate that, I'd have 1 over 8 because 2 times 2 times 2 is 8. And now we can see that 2 to the negative third power, yeah, it is 1/8. And this is why and how it works. Okay? So I'm going to show you a rule. You're going to write it in your notes. But as we do our examples, I'm going to help explain what this means. So here, if I have a negative exponent in the numerator, like I did here with 2 to the negative third power, I'm going to have to move that downstairs. See how it was upstairs and I went, whoop, moved it right downstairs. And when I move it downstairs, the exponent becomes positive. And same thing goes if I have a negative exponent in the denominator. I want to move it upstairs and it will become positive. We always want to remember that the base stays the same. So do you see how the base was a big 2 here? When I moved it downstairs, it still stayed a big 2. The only thing that changes is the exponent. The exponent becomes positive. And when we're writing expressions with exponents, we want all of our exponents to be positive. That's going to help us do this without a calculator. Okay, so let's give this a try. So I'm going to switch it to my notes now. All right, so in my notes, I've got these examples. We're going to keep in mind this little rule, and I'm going to kind of show you how you can use this idea. Okay, what I have here are 3 examples where the negative exponent is in the numerator. So when I'm given a to the negative n power, you can't use a calculator for that anyways. We want to simplify it, and we're simplifying it so we don't have any negative exponents. So I first want to write this as a fraction so that I can determine that this is actually upstairs. So what I'm going to do is I'm going to move it downstairs. I'm going to rewrite it as a fraction, move this downstairs. The base a stays the same. The exponent becomes positive. Now what's in the numerator? Well, it's a 1. And you might be thinking, well, they're just reciprocals of each other, but you got to be careful with that. Do you see how I really could write this as 1 times a to the negative first? So when I move that downstairs, I still have a 1 in the numerator. Okay, and then this would be my simplified expression with no negative exponents. All right, let's try the second one. So here on the second one, I've got 4 to the negative third power. I want to write this as a fraction. I can always write anything as a fraction with a denominator of 1. Now I got a negative exponent, so I want to move that downstairs to the denominator. The base stays the same. The big 4 stays the same. The exponent becomes positive, and I have a 1 in the numerator. Remember, I could rewrite this as 1 times 4 to the negative third. When I move that down, the 1 remains in the numerator. Now I can keep evaluating this. 1 over 4 times 4 times 4 is 64. And of course, if you did this on your calculator, you'd get 1 over 64. Okay, last one here. I want to write this as a fraction so I can see that this negative exponent is upstairs. So I'm going to move it downstairs. The base stays the same. So you guys, the base is the big number, which is a negative 2. That stays the same. The exponent becomes positive and a 1 in the numerator. Now I'm going to keep evaluating because these are numbers, not like letters, so I can keep going. So I have a 1 in the numerator. Now the exponent touches the 2, so it only applies to the 2. So I got 2 times 2 times 2, which is 8, and the negative in front is just going to get carried over because this says the opposite of 2 cubed. So this would be negative 1/8. Remember, the exponent only applies to whatever it touches. Okay. All right, let's take a look at these examples where I have the negative exponents downstairs. So let's try and see how this is going to be different. Okay, so I want to simplify. I can't have any negative exponents, so I want to rewrite this. I see that the negative exponent is downstairs, so I'm going to move it upstairs. The base stays the same, and the exponent becomes positive. Can you simplify it any further? Nope. I wouldn't need a 1 underneath it because we don't write numbers in simplest form with 1 underneath as a denominator. So just x to the third. All right, let's try this one. Now, careful with this one. The 2 has a positive exponent of a 1. It stays where it is. But this is what has the negative exponent. So this is going to have to move. When I rewrite my answer, the 2 stays where it is because it's happy. It's got a positive exponent. The n is going to come up and join it. So the n, the base stays the same. The exponent becomes positive, and then, of course, there'd be a 1 in the denominator, but I don't need a 1 down there. This would just be 2 times n to the 4th power. So the negative exponent just moved upstairs to join the 2. And I can't simplify it any further. All right, last one. I can see here that I have a negative exponent downstairs, so I'm going to move it upstairs. The base stays the same. The big negative a stays the same. The only thing that changes positive is the exponent. And that would be over 1. And of course, I wouldn't need to write it over 1. I'd simplify it and would look just like this. Okay, so these are examples of when the negative exponent is in the denominator, it will move upstairs and become positive. Okay, so now let's take everything we've learned with the negative exponent here and let's see if I can mix it up and you still got it. Okay, so maybe you want to pause the video and try these 3, and then you can come back and see if you have them right. All right, let's check and see if you have them right. So here I want to write it as a fraction so I can determine it's upstairs, so I want to move it downstairs. So the base stays the same, the exponent becomes positive, and there's a 1 in the numerator. I can keep going. 1 over 3 times 3 times 3 times 3 is 81, and this would be my final answer. On the next one, negative exponent is in the basement. It's downstairs. I'm going to move it upstairs. So moving it upstairs, the base stays the same. Big -4, the exponent changes to positive. 1 in the denominator. Okay, remember, the exponent only applies to whatever it's touching, and it's touching the 4. So 4 squared is 16. I'm going to take the negative and just bring it over, and I don't need to write it over 1 because we don't need that in our answer, -16. All right, last one. Can't tell if it's upstairs or downstairs, so I'm going to write it as a fraction. Notice I had to do that with the first one also. Now, it's upstairs. I want to move it downstairs. The base, the big -5, stays the same. The exponent's the only thing that changes to positive, and there's a 1 in the numerator. Let's keep evaluating. -5 to the third power. Now the 3 is touching the parentheses, so it applies to everything in parentheses. The entire -5 times -5 times -5 will be -125. So then this would be my final answer. So you're just simply moving them upstairs or downstairs. The base stays the same. We want the negative exponents to become positive. All right. So now we're going to take everything we've learned, the zero and the negative exponent rule, and we're going to put them together in our notes, 4 examples. Okay, these are the 4 that I'll be going through. So let's see if we can simplify using or applying both of our rules. All right, so it looks like I've got 4 times a to the -3rd times b to the 5th times c to the 0. These are all separated with multiplication. They're all separate terms. They're just squished together with multiply. I see here that I have a negative exponent, so I know I'm going to have to draw downstairs. So let's just make this as a fraction. Now c to the 0. Now remember, anything to the 0 power is 1, so this is just going to change to a 1, and when we're multiplying by 1, it really just cancels this out, doesn't it? So I don't have to pay attention to that anymore. It's really just a 1. Okay, looks to me like this a to the -3rd power, that is a negative exponent. I'm going to have to move that downstairs. 4 gets to stay where it is. It has a +1, and b gets to stay where it is. So let's rewrite. 4 stays in the numerator. B to the 5th stays in the numerator. It's a positive exponent. A, you're coming downstairs. When a comes downstairs, the base stays the same. The exponent changes to positive. And I have all positive exponents, and I am done. Let's try 2. Remember, everything's separated with multiplication. The x to the 6th and the y to the -1st, they're separate. Okay, so let's see here. X to the 6th, you get to stay where you are because you're a positive exponent. But y is going to have to move downstairs, and z is going to have to move upstairs. They're going to have to trade places because they're both negative exponents. Y moves downstairs, and it'll have a +1 exponent. Z moves upstairs, and then it will have a +6 exponent. Of course, I don't need to put a 1 in the exponent, so I could have x to the 6th, z to the, oh, I'm sorry. That would be z to the 4th, and then just over y. Y, again, would not have to have an exponent because it's just y to the 1st. And that would be my final answer. Okay, let's try number 3. Oh boy, lots of stuff going on here, number 3. First of all, keep in mind that this is multiply, and these two are being multiplied. Okay, so q to the 0 power. Anytime you see anything to the 0 power, remember that's just 1, and it's going to cancel out because when you're multiplying by 1, it doesn't change the value of what you're multiplying by. Okay, so we've got p to the -5th. That's going to have to move downstairs. The base stays the same. The exponent becomes positive. The r to the 1st is going to have to move upstairs. R, positive 1st. Now, do you see this one right here? -4 to the -2nd power. That's going to have to also move upstairs because it has a negative exponent. So when I move it upstairs, the base stays the same. The exponent becomes positive. Now we need to continue simplifying. We can evaluate this now that it's numbers. The 2 applies to the parentheses, so everything in parentheses is getting raised to the 2nd power. -4 to the 2nd power is -4 times -4, which is 16 times r over p to the 5th power. So I'm just moving things around, getting everything to be positive exponents, and then I'm simplifying anything that's numerical. Okay? All right, last one on number 4. What is the value of the expression if m is -4 and n is 2? Here's our expression. It's going to be very difficult to start plugging in numbers when you have negative exponents. You don't want negative exponents. So my advice to you, I'd say write this down in your notes on the left. We want to simplify first. Okay, get every exponent to be positive. Now remember, these are all separated by multiplication. I'm going to draw myself a downstairs. Who's moving downstairs? Well, not the 7, not the negative 7. This is a positive 1 exponent. The base is negative. I'm looking for negative exponents. This has a negative exponent, so it gets to move downstairs. Everybody else stays up in the top. Negative 7 stays, and to the third power stays, but m moves downstairs, and when it does that, it changes to a positive exponent. Now I'm ready to simplify. So I've got negative 7. I'm going to replace the n with a value of 2 and take it to the third power, and m, third power. So you see how I'm plugging in parentheses? And that way I can replace n with a 2 and m with a negative 4. And I want parentheses. Okay, so let's simplify here. 2 to the third power is 8. Negative 7 times 8, negative 56. And negative 4 to the third power, that's negative 4 times negative 4 times negative 4. I know 4 times 4 is 64. And so this is going to be negative 64. So a negative divided by a negative makes a positive. So this is 56 divided by 64, which are both divisible by 8. So I would end up with 7/8 as my final answer, simplifying. Okay, so you want to simplify first to get everything to be positive exponents, and that's what we did here. Then once you have that, then you start plugging everything in. Okay, that would be my advice to you with that one. Okay, so let's summarize it. We had 2 exponent rules. Any number to the 0 power is always equal to 1, and a negative exponent upstairs will move downstairs. If you have a negative exponent in the denominator downstairs, they will move upstairs, and the base stays the same. Thank you for joining me.